In these scientific examples, we will be using our background knowledge of solving equations to solve for reaction time using the physics motion equation x equals vit plus 1/2 a times t squared, with t representing time, a representing acceleration, or in this case gravity, x representing distance, and vi representing initial velocity. This equation is pretty much the same equation we used in our second mathematics example, except the variables are just different letters, but overall they represent the same things. In our first example, we will be using the average distance dropped before I was able to react and catch the ruler in our experiment. In our equation, we have a distance of 0.206 meters, an initial velocity of 0, and an acceleration of 9.8 meters per second squared, which is the acceleration due to gravity. Just like when we solved algebraic equations, we want to solve for t by isolating it. Let's start with 0 times t. 0 times any number is 0, so 0 times t is 0, and therefore we can remove it from our equation. We are then left with 0.206 equals 1/2 times 9.8 times t squared. Next, we're going to simplify the equation by taking 1/2 times 9.8. 1/2 times 9.8 equals 4.9. Our equation now reads 0.206 equals 4.9 t squared. Now, we want to isolate t squared by dividing 4.9 from each side. 4.9 divided by 4.9 is 1, and 0.206 divided by 4.9 is 0.0420. Therefore, t squared is now equal to 0.0420. We can finally solve for t by taking the square root of each side. Remember that the square root is the opposite of a number squared, which is a number times itself. So, we are figuring out which number multiplied by itself is 0.0420. This is very difficult to calculate by hand, so we are going to use the square root button on our calculator to figure it out. The square root of t squared is t, and the square root of 0.0420 is 0.205. Therefore, t equals 0.205 seconds. My average reaction time is 0.205 seconds. Now, in our second example, we're going to solve for how fast a person would have to react in order to catch the $50 bill. In this example, we are going to be using the distance of a $50 bill to solve our equation. In our equation, we have a distance of 0.076 meters, an initial velocity of 0, and an acceleration of 9.8 meters per second squared, which is again the acceleration due to gravity. Again, we are solving for time. Just like in our first example, we can eliminate 0t from our equation because 0 times any given number is 0. We are now left with 0.076 equals 1/2 times 9.8 times t squared. We can once again simplify the equation by multiplying 1/2 and 9.8, which we know is 4.9. 0.076 equals 4.9 t squared. Now, we are going to isolate t squared by dividing each side by 4.9. 4.9 divided by 4.9 is 1, and 0.076 divided by 4.9 is 0.0155. T squared is now equal to 0.0155. We can finally solve for our reaction time by taking the square root of each side of the equation. The square root of t squared is t, and the square root of 0.0155 is 0.125. Therefore, our answer is t equals 0.125 seconds. You would have to have a reaction time of 0.125 seconds to be able to catch the dollar bill.